Today we're going to learn the third way that we can solve a triangle. So let's remember what we've done so far. So far we've used SOHCAHTOA and we've used the law of sines to solve triangles. So by the end of the day today, you should be able to use our third version of this, which is the law of cosines, to solve any triangle. And then from there, applications are pretty straightforward. But the most important part of today is we need to be able to know, when do I use the SOHCAHTOA, when do I use law of sines, and when do I use law of cosines? Because when it comes to just generally solving a triangle out in the world, they're not going to say use this one. You have to know, oh, use this method to solve this triangle because of these things. So we'll get to all of that as we go. But let's start at the very beginning here with our problem for Caitlin. Caitlin was given a problem and we just learned the law of sines. And so Caitlin says, okay, I know that I've got side B is B, side C is 8, and angle A is 35. And I know how to draw a standard ABC triangle where angle A would be here and side A would be opposite that. Angle B, we would put that one there, but we can put it anywhere, but side B is opposite of it, and angle C is going to be that third angle, and we're going to put side C opposite of that. And she goes, okay, it's not a right triangle, can't use SOHCAHTOA. And then she says, wait a minute, I don't have a pair, and I don't have a way to make a pair, so now what do I do? This is where Caitlin needs to learn our third method, which is the law of cosines. Okay, the law of cosines is this law right here, and you can use it with any triangle. And it should look kind of like somebody did something familiar and then messed with it a little bit. In fact, if I take this and like get rid of this part right here and get rid of these two right here, what theorem do we have? That's Pythagorean theorem. And with some very important trigonometry and geometry and some other things, they came up with, well, we can actually extend Pythagorean theorem to any triangle, not just a right triangle, if we add on this little extra bit. Now, really you only need one of these formulas, but I find that depending on whether I'm trying to find angle A, angle B, or angle C, or side A, side B, side C, it's helpful to have all three of these. But if you look, this C, A, B, C, the order goes backwards here. It kind of mirrors here, A, B, C, B, C, A, right? We're kind of following the same pattern for each of these. We're just rearranging them in different orders so that we can more easily use the formulas. Okay, so this is our law of cosines, and this is what we're going to use to solve Caitlin's triangle. So again, let's draw her ABC triangle, where angle A, we'll put that here at 35 degrees. We don't know side A. We don't know angle big B or angle big C, but we know side B is 5 and we know side C is 8. And remember, when we're solving a triangle, that means that we want to find the missing angles and the missing sides. So we need to find, what does side A equal, what does angle B equal, and what does angle C equal. Okay, so let's go ahead and pick one of our formulas. We don't have a pair, so we have to use one of our formulas. Now, it's easiest to go, okay, which angle do I have? I have angle A. So I am going to pick the formula that uses angle A in it, since that's the one that I have. So if you have one angle, pick that formula with that angle in it. So we're going to start with A squared equals B squared plus C squared minus 2BC cosine of A. And that BC is times the cosine of A. Now you're probably already guessing what the next step is. I know what B and C and big A are, so we're going to go ahead and plug those in. So that's going to be 5 squared plus 8 squared minus 2 times 5 times 8 cosine of 35 degrees. Okay, You could simplify things at this point, but my experience is students who try to simplify at this point end up just messing things up. So at this point, what I want you to do is take this right-hand side and type it into your calculator exactly as you see it. Well, almost exactly. Sometimes calculators don't like when you use parentheses, so use time signs at the 2 times 5 times 8 cosine 35, and that might work a little better and avoid a few errors. So 5 squared plus 8 squared minus 2 times 5 times 8 cosine of 35 degrees. Don't forget to close that. Don't forget to make sure you're in degree mode, and we get 23.4678 and a lot of decimal places. So a squared is 26.468, I believe. I forgot the number. 23.4678, blah, 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 blah. And that number is just going to keep going forever. Now, is that a? Do I have a at this point? No, I do not. How do I undo an a squared so I get just a? Well, the opposite of a squared is a square root. So what I want to do is square root this whole thing with all of those decimal places to avoid round off error. And there's a really neat trick with most calculators. If you want to take the square root of the thing on the screen, what we can do is we can use the ants button. And the ants button on this calculator is down at the bottom next to the equal sign. So if you look kind of down here at the bottom next to the equal sign, there's where you see A and S. What that means is take the answer on the previous screen and use it. So we're going to do square root of the answer on the previous screen, and we're going to get that the answer to this question is 4.84. So now A is 4.84, and now we have one of the pieces that we had to find. Okay, but now we know that A is equal to 4.84. Well, what does that do for us? Well, if we know A is equal to 4.84, now what do we have? We have a pair. We have angle A, which is 35, and side A, which is 4.84. So now that we have a pair, what theorem can we use now? Yes, the law of cosines, or sorry, the law of sines. So we will do sine of 35 degrees over 4.84 because that's our pair. And then it really doesn't matter which one we pick. Let's go ahead and find side angle B. So we're going to do sine of B over the opposite side, which is 5. We'll cross multiply. 4.84 sine B is equal to 5 sine of 35. And divide both sides by 4.84. So now we can see that sine of B is equal to 5 sine of 35 over 4.84. But is that angle B? No, that's the sine of angle B. And what do we do when we have the sine but we want the angle? What magical button do we use in our calculator? That's right, we use the inverse. So in this case, it's a sine. So we will use sine inverse of 5 sine 35 degrees over 4.84. And we will put that into our calculator very carefully. Make sure I can see this. Here we go. Okay, so sine inverse fraction 5 sine 35 over 4.84. Arrow out, close, and we get 36.34 degrees. So that is B is 36.34 degrees. Now, I know that side little a was 4.84. I now know angle big B is 36.34. How do we get that last angle? That's right, they all have to add up to 180. So our 35 plus 36.34 plus angle C has to equal 180 degrees. Doing some quick subtraction, we will see that C is equal to 108.66 degrees. Okay, if you have to find all of the pieces of a triangle, this is what you're going to have to do. You start with the law of cosines to find that first angle or that first side. Now you have a pair, we can use the law of sines. Once you've got that done, you can go ahead and use subtraction to find that. Be aware that you may have some round off error. So if you are doing all three of the missing pieces and the third angle is it's telling you it's wrong, try rounding up by 1.01 and see if that helps with a little bit of the round off error. But this is in general what we do. Now, if you are just trying to find one side, then you can use any of these three up here that you want to use. So let's say you had something like this where it said this is 22 and this is 28 and this is 13 degrees, find X. Well, I don't have an X, so you can pick it to be anything. So I like to pick X to be C, and I like to use this one. So that way we can see, it's just easier for me to use that. Once I find that one side, then I can stop. I don't have to keep going because this question would only ask me to find the one side there. All right, now that was kind of the easier version of this question. Let's go to the second version of this question, which is a little bit more difficult. So let's look at this guy right here. We want to solve the triangle where all they have given us is little a, little b, and little c. And what do you immediately notice there are none of? There are no angles. And if you have no angles, now this is going to be the most difficult of them. Now, we've got to be careful. When you are being asked to find all three angles, you have to always start with a specific side. If they are asking you to find one particular angle, one particular angle, like if they come into this and they say, I want you to find angle A, go ahead and just start by finding angle A and using that formula with the A in the formula. But if they say you got to find all three of these, then we have a rule. What we don't want is we don't want to get stuck in the ambiguous case of the law of sines. And that can happen really easily. But there's a very easy way to avoid this. So if they tell you to start by finding one particular side, find that side and ignore what I'm about to say. But if you have to find all three sides, then you always start by finding the biggest angle. Well, which side is the biggest angle opposite of? Remember, if you think about our geometry lessons, the biggest angle is opposite the biggest side. The smallest angle is opposite the smallest side. So you're going to always start with the letter for the biggest side if you are finding all three. Again, only if you're finding all three. If you have a problem that just says find this one side, then just use whatever side that you need to use, and that should be the equation that you're picking. Or find this one angle, use that equation for that one. Okay, so this is telling us we have to find all three angles. So what is our biggest side? Well, that is 8, which is B. So we are going to start with B squared equals A squared plus C squared minus 2AC cosine of B, because that is the angle that is opposite the biggest side. Now we're going to plug stuff in. So B squared is 8 squared equals 6 squared plus 5 squared minus 2 times 6 times 5 cosine of B. Okay, so we've got this going. We're going, all right, let's figure this out. Let's do a little math here. So 8 squared is 64, 6 squared is 36, 5 squared is 25, 2 times 6 times 5, that's minus 60, times the cosine of B. Now, I am going to show you the biggest mistake that happens, and I want you to not do it. So here's the biggest mistake that I get. I get students that say, okay, 36 plus 25 minus 60, and they take all three of these guys and they add them together. Okay, so we're going to grab our calculator and we're going to see, okay, 36 plus 25 minus 60 is 1. So then they say 64 is equal to 1 cosine B. Well, then all I have to do is that B is cosine inverse of 64. And then when they put that in their calculator, they get an error. So they're saying, well, this triangle doesn't exist. Well, the triangle does exist. We just drew it. We can see it. The triangle exists. So this was wrong. Can you see what I did wrong and what is the most common mistake that happens here? So we know that this stuff down here is wrong. So we're going to erase it. I hope you didn't write it. If you did, that's okay. Go ahead and erase. What is wrong? Well, this 36 and this 25 don't have anything on it, but this 60 has a cosine with it. So can I put the 25 and the 36 with the thing that has the cosine? No. But can I put the 25 and the 36 together? Yes, yes, I can. So just be really careful here. So we're going to get 64 equals 36 plus 25, which is 61 minus 60 cosine of B. Now, very carefully, how do we get cosine of B by itself? Well, first we have to subtract 61 and be very neat here, y'all. The biggest mistake that I see is that people try to skip steps and it gets messy and then they lose track of things. So 64 minus 61 is 3. And notice this minus sign is still here. That negative is still on the 60 for this particular problem. Now we're going to divide by negative 60. And we get that cosine of B is equal to negative 3 over 60. So then again, if I have a ratio and I want to know an angle, what buttons in my calculator give me angles? Well, the inverse buttons. Now, should I use sine inverse or cosine inverse on this one? Well, since it's a cosine, I should use that B is the cosine inverse of negative 3 over 60. And we will put that into our calculator. Cosine inverse of negative 3 over 60. And notice I didn't need to reduce that fraction. I could have, but it doesn't matter because I'm just sticking it into a calculator and I get 92.87 rounded properly. So this is 92.87 degrees. Okay. Now that I know that big B is 92.87 degrees, what can I do on this picture? Well, this is 92.87 degrees, and now what do I have? I have a pair. And as soon as I have a pair, what can I do? The law of sines. We're going to go a little bit faster at this point. So sine of 92.87 degrees over its opposite side, 8. Let's go ahead and find the next biggest or the smallest side here. So we're going to find angle C. So we're going to do sine of C over 5. We'll put those together. So cross multiplying and skipping a little step, we're going to get that sine of C is equal to 5 sine of 92.87 degrees over 8. So C is sine inverse of 5 sine of 92.87 degrees over 8. And we will put that into our calculators. Let's go ahead and model that using our online calculator here. Again, notice this one is a sine inverse. We're back to the law of sines. So 5 sine 92.87. Don't forget to close that parentheses. Over 8, close that parentheses, and we get 38.62. And then the last one, of course, is the easiest angle because they must add up to 180 degrees. So we take off that 38.62 that we just found, and we take off the 92.87 that we found, and we end up with our final answer, which is 48.51 degrees. And again, when you're doing a question like this where it's asking you to find all three, start with the biggest side. But if it's a question where it's asking you to find just one particular angle, just start with that angle and go on. It's not going to like throw you into an ambiguous case when you're only finding one angle. But if you're trying to find three angles, you could end up in an ambiguous case. So you want to start by finding the angle opposite the biggest side in that case. Okay, last thing we need to do is, when you get to like a test or you're just trying to figure out a triangle in the real world, they're not going to be like, use the law of sines on this one. It's not going to work. Okay, so how do I know when I can use SOHCAHTOA and Pythagorean theorem versus when am I going to use law of sines versus when am I stuck using the biggest, ugliest, difficult one, which is the law of cosines? So just remember, what do we have to use Pythagorean theorem or SOHCAHTOA? We must have a right triangle, meaning we have to have a 90-degree angle in our triangle, and then we can use SOHCAHTOA. There is no such thing as SOHCAHTOA. There is no such thing as Pythagorean theorem if we are not working with a right angle. Now, if we know we are not working with a right triangle, then how do I know I can use the law of sines? Because that's the easier of the two laws. Remember, we must have numbers for a side angle pair. You must have numbers for a side angle pair. Then you can use the law of sines. If you don't have a right triangle and you don't have numbers for a side angle pair, then you're kind of stuck with the law of sines. So we only use the law of sines if you don't have the above. If you don't have any of these above, it's not a right triangle, we don't have a side angle pair, then we're stuck with law of cosines. You use it once and then you backtrack and use law of sines if you have to. All right, that is the end of our last section for this unit. Good luck, everyone.